Okay, so this is another example where we're going to be using integration to locate the centroidal y distance. So if we're going in the y direction, that's going to be going up, y direction, for the shaded area below. And so if we kind of look at this, my guesstimate is it's going to be somewhere in this position when I'm going up. The other thing to note is before all of our examples, we were completely shaded in below or above. And this example, we are bounded by two different sets of equations. So we're going to have to make sure that we can figure out a relationship between this whole thing, which would be all the area underneath it, okay, minus this curve, which would then remove that area and leave this grade. So the first thing we're going to do is we're going to set up our system for each piece. And if I were to look at the entire triangle, okay, so this is going to be y2 equals x, and we are bounded here by 4 feet, and we're bounded here by 4 feet. And if I were to just draw a rectangular section, then I can see I'd be integrating dx. This distance up is y. This distance over is x. And if I'm specifically wanting to know the y distance, so that's going to be y bar equals, and we're going to have y tilde dA divided by dA. So if we need y tilde, then I can look at this picture, okay? But let's not quite get there yet. Let's just leave it like this, because I'm going to have to subtract off this lower area. Okay, so if I have all of this minus, okay, same bounds, all of this, I'm going to be left with this little wedge in the middle. So this is bounded by, okay, y1 equals 1/4 x squared. And if I go on here, then I can see that I have a centroid. It's x over dx, and it is also y tall. So we're going to need to make sure we name this one y2 and this one y1, because they are each a different curve. So now we can go back and draw that little potato chip wedge. Okay, so it comes up, comes down, it's like a Pringles. And we are bounded by 4. And I need to look at a rectangle that's within this. Okay, so if I look at this, then it is y2 tall, okay, and I am subtracting out, if we look right here at this little rectangle right here that's gone, I am subtracting out y1. So this rectangle that's left must be y2 minus y1. And when I look at tilde, it's got to be right here in the center of that, so it's going to be y tilde. Y tilde equals, what is y tilde equal? It equals y1. I don't know why I made that a prime. Okay, I'm subtracting out this y1 here, so y1. Okay, plus y2 minus y1 divided by 2, because I'm going halfway up that wedge. Okay, so y tilde equals y1 plus y2 over 2 minus y1 over 2. And I can rewrite this again, that we have y1, okay, which would be like 2 over 2, minus y1 over 2. And I'm going to get y1 divided by 2 plus y2 divided by 2. And I'm noting that we have to integrate with respect to x, so I need to get rid of these y's, so I can go back up to the curves and I can see that y1 is 1/4 x squared and y2 is x, so y tilde equals 1/4 x squared over 2 plus x over 2. And I can then Rewrite this again as x squared over 8 plus x over 2. So here is my equation for y tilde. And now I need to work on dA. Sorry. Let me get this focused again. There we go. So dA. So dA again is this little tiny rectangular differential element. And when I look at the height of that, I have y2 minus y1, and the base is dx. So I have to go back through the same exercise, and I know that y2, I've got it all covered up. Sorry about that. If we look at that, we have y2 minus y1. So y2 is x minus, and then y1 is x squared over 4 dx. Okay, so continuing simplifying, I can see that I'm going to have to do a y tilde dA. So I'm going to have x squared over 8 plus x over 2 times x minus x squared over 4. And I need to multiply those out. And as I always tell my kids at home, algebra is probably the hands down most important class you'll ever take, and it's the one you probably need to know the most about. Because even when we're integrating, we are doing algebra. So let's multiply this out, and I get x cubed over 8, okay, FOIL, minus x to the 4th over 32, plus x squared over 2 minus x to the 3rd over 8. And goes away, and I'm left with x squared over 2 minus x to the 4th over 32. So that's what I'm going to be integrating. So I'm going to come back up here to this blank part of my paper. You see it over there? Okay, you can see it over there. So if y bar is y tilde dA divided by dA, well, I now have, okay, I already found it over here, x squared over 2 minus x to the 4th over 32 dA, and I don't know why I keep wanting to put a dA there, dx. And remember, if I'm integrating with respect to x, the bounded area is from 0 to 4 feet divided by 0 to 4, and I need to make sure I get my area there. And so we had x minus x squared over 4 dx. So now we can start with our integration. So I'm going to add a term, so I'm going to have x cubed, okay, and I've already over 2, and then I'll have to make sure I multiply by 1/3, okay, minus x to the 5th over 32 times 1 over 5 from 0 to 4 divided by x squared times 1/2 minus x cubed over 4 times 1/3 from 0 to 4. So I get x cubed divided by 6 minus x to the 5th divided by a pretty big number, 5 times 32 from 0 to 4, divided by x squared over 2 minus x cubed over 12 from 0 to 4. I'll move my paper up for you. So I know I'm going to start substituting my values in. I know that the 0, it'll be, you know, this nonsense with 4's in it minus this nonsense with 0. Well, that's because 0 is going to make both those terms go to 0. We can just focus on the 4. So I have 4 to the 3 divided by 6 minus 4 to the 5th power divided by 5 times 32 divided by 4 squared over 2 minus 4 third over 12. And when I simplify, I'm going to get 4.27 feet divided by 2.67. I guess we don't really want the feet on there because it's going to be feet squared over feet if we really think about units. And when I divide that out, I get y bar equals 1.6 feet. Okay, and we are going up. All of our area was above, so 1.6 feet up. So I'm going to come back here and look, and I'm going to say, okay, so if 2 is kind of like right in here, I am below that, and quite honestly, I probably made that too high, because if you look at the potato chip wedge, see that it is probably going to be kind of a lower value. So there we have it. That's how we would integrate if we needed to find the wedge between two separate curves.